In this lesson, you will learn how to identify key features of functions. Our first key feature is intercepts. An x-intercept is where the graph crosses the x-axis. In a table, you can identify the x-intercept when y is 0. So you can write an ordered pair for an x-intercept. It will be an x number, comma, 0. A y-intercept is where the graph crosses the y-axis. In a table, the y-intercepts when x is going to be 0. As an ordered pair, you can write it 0, comma, your y number. So let's look at some examples. Number 1, here we have a graph of an exponential function. Our x-axis runs along here horizontally, so our x-intercept we have none. It is possible for a graph to not touch or cross the x-axis. The y-intercept, here is this vertical axis. It has a point here at 0, 4. You should always, when naming your intercept, list it as an ordered pair. Also notice that the x value of the y-intercept will always be 0. If you find it to be anything else, stop and find your mistake. You've done something wrong. Let's look at example 2. Our x-intercept, because this is a quadratic, it actually crosses 2 places. So we have -2, 0, and we have +2, 0. If you have 2 points where the graph crosses the x-axis, then list both of those. Again, notice here, the x-intercept has y values that are zeros. For our y-intercept, would be 0, 8. Notice something kind of neat about quadratics. The y-intercept, which is 8, is the same as the c value. That will always be true when equations are in standard form for quadratics. The y-intercept will be the same as the c value. Let's look at example 3. So we have another quadratic here. We have only one x-intercept at -2, 0. And we also only have one y-intercept. So 0, 4. Notice we will not see this 4 in the formula for the quadratic because this is in vertex form, and this 4 would have shown up only if it was in standard form as that c value. Let's look at some tables to find intercepts. When we look at a graph, we know we can just find where it crosses the x or y axis, but a table doesn't show that. However, we do see some zeros in our table, and that can help us identify x and y intercepts. So it's always helpful if you just circle all of those zeros that you find within the table. Look for multiples because we know we could have more than one x or more than one y intercept. So 0, -3. Let's go back and think about our graph. 0 along the x-axis, -3 on the y-axis, that would have to cross at the y-intercept. So 0, -3 is a y-intercept. So that would make 2, 0, +2 on the x-axis, 0 on the y-axis, that would be an x-intercept. So with x as a 0, it's going to be your y-intercept. As y as a 0, it's going to be your x-intercept. Our next example, it's a square root function. That wouldn't matter for this problem or not. Again, find your zeros in your table. Here we have a 0 in the x column. Here we have a 0 in the y column. We have to assume that there's no other intercepts if this is all that it's given us. So our intercepts here, because we have a 0 in the x column, this would be our y-intercept, 0, 2. And because this one has a 0 in the y column, it would be our x-intercept at 4, 0. You could always check those by sketching out a little graph and plotting the points at 4, 0 and 0, 2 to make sure they fall on the correct x or y axes. Let's look at example 6. Here, a cube root function. Find your zeros. And we do have just the 1 point. So because the x is a 0, that makes it a y-intercept. And because the y is a 0, it also makes it an x-intercept. The origin, 0, 0, passes both through the x and the y-axis. So it is possible to have the same point for x and y-intercept at the origin.